Hello again. In this video, we're going to talk about research designs and what they have to do with statistics. We're basically talking about two different types of designs, experimental designs and non-experimental designs. Let's talk first about experimental designs. There are three different characteristics that we associate with experimental designs: the independent variable, the dependent variable, and groups. And we're all sort of familiar with this already. We've talked about the independent variable and the dependent variable and the fact that we use groups in experiments. The goal of an experimental study is to show cause and effect between two variables. And this is one way in which you will be a better consumer of statistics, is a lot of times people will try to throw around research showing one thing causes another, but an experiment wasn't done. Maybe it was some non-experimental method, but only experiments can show cause and effect. So there are two characteristics in an experimental design. There's manipulation and then there's control. So manipulation, we've already talked about a little bit. It's the ability to manipulate or assign people to the independent variable. And the ultimate goal is to show cause and effect of the independent variable on the dependent variable. We're showing that the independent variable did somehow affect the dependent variable. Control in this case establishes cause and effect through two groups and random sampling. Let's take a closer look at that. When we do an experiment, we have an experimental group and a control group. The experimental group receives the independent variable, or the treatment. The control group does not receive the treatment. Cause and effect is shown by comparing the scores of the groups and showing that there's a systematic change between the two groups. It's not attributed to random events, and it's not just by chance. Random sampling is a very important key to this whole puzzle. And we only can accomplish random sampling when there's a known list from which the sample is drawn, and each person in the population has an equal chance of being selected for the study. In addition, there's replacement for those who are selected, and this is something we'll talk about more as the semester goes on. Random sampling helps us to reduce the systematic bias between groups. It doesn't guarantee a representative sample, but it may improve representativeness. So it's one good effort towards having a representative sample. Here's an example of what a research experimental design looks like. So we start with a population, and from that population we do random sampling. Every person in the population has an equal chance of being chosen. And once they're randomly selected, they're assigned to either an experimental group or a control group. And this diagram uses a study that we talked about previously with the indoor lighting. So the experimental group is exposed to indoor lighting, maybe extra indoor lighting. The control group doesn't have any extra indoor lighting. At the end of the experimental period, both groups are measured on their depression levels, and then they are compared. And this is what an experimental design looks like. And if the experiment shows a difference, that would mean that indoor lighting perhaps decreases depression levels. I'm guessing that's what this study is proposing. So in addition to experimental designs, we have non-experimental designs, and these are considered field studies. This is where behavior is observed. And observations are made in the natural environment, but there's no ability to manipulate variables. There's no ability to control the environment. This is just where we are out there in the wild collecting data and seeing what's out there. We're not able to establish cause and effect as a result of the fact that we're not manipulating any variables. So non-experimental designs examine relationships between variables, but really can't establish cause and effect. There's no control group, and the independent variable is not manipulated. So one type of non-experimental design is correlation. And this involves measuring two variables for each individual and describing a relationship between the variables. There's no causation We can't say that there's causation. We can only say that there's a relationship. Here's an example of a correlation matrix. And so on the left, we have a table that shows a bunch of kids, the time that they spent studying, maybe it's the hours they spent studying, and the grade on some test. And what we do is we take each score and we plot it on the correlation matrix. So let's take a look at Alan. Has a score of 5 and a grade of 70. So I'm going to go to the grade of 70 and up to about 5, and this dot represents Alan. So Bess has a time of 1 and a grade of 50. So this dot represents Bess. And what we can tell is if there's a relationship between these two things. And we're going to talk more about correlation later in the semester. But right now what I'm seeing is lower scores on one variable are associated with lower scores on the other variable, and higher scores on one variable are associated with higher scores on the other. So there seems to be a positive relationship between the amount of time you spend studying and the grade that you get in the class. So this is an example of a positive relationship. As study time goes up, grades go up. As study time goes down, grades go down. There's a systematic relationship here. Let's do a learning check that's going to put together everything that we've talked about so far in lesson 1. A researcher is interested in the relationship between caffeine consumption and activity level for elementary school children. A sample of 200 children is obtained, and the children are separated into 2 roughly equivalent groups. One group is given a drink containing 300 milligrams of caffeine, oh my, and the other group gets a drink containing no caffeine. The researcher then records the level of activity for each child during a 30-minute session on the playground. So what I'm going to ask you to do, and I'm going to hope that you're going to pause the computer and write down your answers. This is a good way of checking your knowledge. Identify the population, the sample, the independent variable, the dependent variable, and the type of design. Pause the video and come back. I'll be here for you. So the population was elementary school children. That is the total population. The sample was the group of 200 children that were pulled aside to be studied. The independent variable was the type of drink or the caffeine drink. The dependent variable was their activity level, and this was an experimental design. Let's do another one. A researcher wants to study the relationship between smoking behaviors and incidence of skin cancer. A group of smokers with an N of 50, which means there are 50 people in the study, are recruited to participate in the study. Why couldn't this be an experimental design? Go ahead and pause your computer to think about it and then come back. Well, this couldn't be an experimental design because, first of all, there's no manipulation of an independent variable, and there's no control group. And finally, it's not ethical to randomly assign non-smokers to a smoking group. All right, this concludes this video on different types of research designs. And in the next video, we're going to talk about something called scales of measurement. So we'll see you there.